All right, we're over at the drill press. We have our material here, our bracket that we've been working with. We have our radius that was cut from the bandsaw. We have this radius that was cut off here. This originally was cut from the miter saw. The material here that we're looking at has a kind of a teardrop shape that needs to get cut out of it. And so what we're going to do is we're going to end up over at the scroll saw making that cut. However, in order to access the scroll saw, we're going to use a drill. In this case, we're going to use a drill press just so that we can make sure we understand how to use that appropriately. But we'll talk more about how the scroll saw accesses this when we get going. So the drill press is used for precision drilling. It's one of the tools that is underestimated in the lab because it seems so innocuous. It's just a drill moving up and down that it ends up, because it's a rotary tool, being very dangerous. A lot of people don't respect it until it's too late. So we're going to go over the drill press here, talk about some different concepts, and then get going. When we're setting up the drill press, a few things. Each drill press comes equipped with a rack of tools that allows you to do all of your clamping and vicing, as well as any of your Forstner bits that are necessary for the piece. A Forstner bit is designed for a much larger hole, so we can look at a Forstner bit off of a table here. So this is a Forstner bit, and Forstner bits are meant to cut into wood. All of our Forstner bits are meant to cut into wood. This is, for instance, a 1 5/8 Forstner bit. Our Forstner bits range at the set all the way up to 2 1/8. However, we do have a few larger Forstner bits that are accessible, but we don't have them. We only have one or two different, one size of that goes above that, or one set of that goes above the 2 1/8. So we have Forstner bits. We have vices where we vice to the table. In this case, we're using T-nuts and nut and standoffs to do our vicing. Because it's such a small piece, we could do a traditional clamp on the edge if it was a much larger piece. Because this is not a small piece, if we had a larger piece, for instance, a larger piece that would look like this, this piece, if we were vicing this down, we'd make sure it is to the left side of the column, so that way when it if it were to break loose, it would hit the column. So that leads us to setting up and properly being aware of the anatomy of the drill press. We have our table, which we're going to vice and clamp things to. We have a piece of wasteboard that's on the table. These tables for these drill presses do not have a pass-through, so we have to make sure that we are setting our depth gauge, which is located here, to appropriate depth, so that way we don't drill a hole through the material, through the wasteboard, and then into the table itself. So we want to make sure we have that. So we have our table, we have our work holding material, we have our chuck, which is going to hold our drill bit. In this case, we're using a 1/2-inch drill bit. We have our depth gauge set here so that we can only move the chuck up and down so to the correct depth to avoid going through into the table. We have our arm here or our arm or wheel. It's a little bit different on drill presses, but we have basically our armature where we're able to extend or retract the chuck with its with its tooling in it. We have our guard, which slides down like this and puts an extra layer of safety between the drill bit and your eyes, your face. So we are able to slide that up and down. Okay, start and stop are available. Basically, the guard is up to stop you from putting start and stop down before you move the guard into place, so you're aware of that it needs to be moved. So the guard will be up in the start and stop zone, so you have to actually make an effort, and that should remind you to move that back into place. So when you're putting your tooling in, the guard should be up until you're ready to operate. Okay. When it comes to our drill presses, you do have the option of selecting speeds and feeds, basically. The feed is going to be based on how fast you as the operator raise or lower the drill working. The speed is going to be dictated by what you set up with regard to your spindle speeds. Our spindles can be, the spindle speed can be adjusted per the material that you're using, as well as the diameter of the bit. So if you're using a 1-inch bit, a 2-inch bit, a 1/2-inch bit, a 1/8 inch bit, with a material, you may find that you have different speeds. I'm going to ask that each and every one of our students has a hands-on, one-on-one conversation, or at least a face-to-face conversation when it comes to setting speeds with our drill presses, because there's one extra piece that I want to make sure that we discuss with regards to the safety of working with our drill presses here at Nicolet High School. So here we are, we have this drill press. We're going to set this up so that we can accept this 1/2-inch drill bit. The table at this point is set up where it's too high for me to actually put my drill bit into the chuck. So what I'm going to need to do, and I'm going to stay to this side so that you can see it, I have to reach around and loosen the clamp on the column. And then I'm going to lower the table by cranking this down. And I'm going to pay attention to how far I'm down so that I can accept this drill bit and still make my cut. That looks pretty good. I'm going to clamp this back up with the column clamp, tighten that up as tight as I possibly can. Give the table a little wiggle, it doesn't move, so I know that that's in position. Now, with the chuck, all right, I can spin this open so that it can accept, and it has its jaws come down on the bit. I can't hand tighten this like I do with our hand tools. I have to hand tighten that just so that drill bit's in place and position. And then I have to reach back here and get our chuck key, okay? Our chuck key slides into our chuck. We tighten that up. I rotate it so that I can tighten each and every one of these up, just so that I can feel secure that this bit isn't gonna go flying, hit anything, and reduce and loosen up. So I've got that chuck in there, I've got that bit into the chuck, I've tightened that up nice and tight. Now I know that I have my bit. I can position the bit over the X that I drew on the piece earlier so that I know where I'm going to be drilling my hole. So it's about positioning and getting everything where I need it. So I'm going to move my tooling, or I'm going to move my work holding around, get to a position where I check to see that my tooling is going to hit the hole, where I want. That looks good. So what I'm going to do here is I'm putting two on here just to ensure that I'm not going to have any loose ends with regards to making this piece stay secure. So I'm holding that in nice and tight. I'm hand tightening everything. Check again to make sure that's where I want it. Yep, okay. I'm going to move this off to the side. So I'm getting, again, some more surface area, holding that in place. It's not going to go anywhere. All right, again, I'm hand tightening this. Now, I need to make sure that I use a wrench that's, again, located on your workstation, as is all of your work holding. And I'm going to make sure that I tighten this up nice and tight. I hand tightened it, but turns out, hey, I can wrench this 3 good turns, and I can wrench this 3 good turns. That's not going anywhere. So now my work holding is holding and securing my material. I have that in place. Check again just to make sure I got that where I want it. Yep, nothing moved. Okay. Now I know that this material is about a 1/2 inch thick, and I know that my work holding or my wasteboard is about 3/4 of an inch thick. So I go down and I get to that 0 mark, or I get to that 0 out where it says 0, and then I'm going to back that off so that I know that I'm at about a 1/2 inch, just a little bit past. I'm going to go 5/8 through so that I know that I get through the material, but I'm not going to go through my waste board. I now have that piece in place. I've got that set up. I know that I'm not going to hit anything. I'm going to slide the guard down, making sure that I have that guard in place. And then I can hit the start button, get my speed up. I previously set my speed so that I'm in a really good speed for this bit. All right. and I'm going down. Again, how fast I lift and raise the bit is going to determine how fast I make my cut. All right, notice I'm not forcing this bit through. I'm not starting a fire where I'm going really fast and getting smoke or chips that are really hot. All right, I've hit the bottom of my, all right, I've hit the bottom of my piece. I'm gonna pull back. I'm gonna see, yes, did I go through? Turns out I was a little bit short. It's always good to be a little bit short when you're going through. You can always readjust. Cut through, yep, I'm done. All right, turn that off, okay? I can move the guard back out of the way. I can see, yes, indeed, I went through the way I want to, and I've got this set up, and I got this all taken care of. It was a little bit long procedure to get this set up just for that simple hole, but it's really valuable when it comes down to making sure that I have a very precise hole for where I want it to be. That's the value of the drill press, is you can get a lot of repeatability, a lot of accuracy. So you got your precision and accuracy. It can give you a nice tolerance and allowance with regards to your ability to pick the right tooling to achieve the right amount of fit and finish with any of your components fitting together. So this is optimal for that, for making sure you have that nice straight up and down, where you might not be able to achieve that with a hand drill. One other option we have here is if we are going to be doing some repeat processing, now that I've got this all set up, I do have the ability to put my work in progress sign up here on the hook. It's going to cover up the on-off switch so that I know that, again, this is a work in progress. So if I'm going to go away, come back in just a few minutes, or maybe I'm going to have a resource period or something along those lines, that tells us for somebody not to come along and take this all apart. And then you have to do it all over again. So we're gonna take that off, and then we're gonna take this apart. So taking this apart is real simple. First things first, remember the drill bit, if it was doing a lot of work, could be hot. So give that some time to cool off, so you can always take care of your work holding first. Okay, so take care of your work holding, where we're getting that out of the way. And we've got that taken care of. And now we're gonna release that. All right. And it always seems like taking this stuff apart comes apart a lot faster than it went together. Again, your responsibility is to make sure that you're putting things away. So you put the nuts and the T-nuts and the washers, if you use washers or standoffs, you put those back. Every drill press is equipped with a full set of tooling. It shouldn't go wandering off or anything along those lines, because we have plenty of work holding for all of our tools. This should be exclusive for the drill press. These T-nuts and standoffs shouldn't go walking away. In fact, there's no real reason for them to be anywhere but over here. So setting this up, moving this out, and then we have our hole and we have our waste board, and now we have to remove our tooling. So one thing, making sure this is definitely cooled down. We just release this, again using the chuck key to get that out. I have that. I want to make sure that I don't drop it, because if it chips and hits this table, it could chip, crack, break. And then we have to throw away that tooling because we don't use dull tooling or broken tooling in an operation in this lab. That is the drill press. Again, that's just a simple version of mounting materials to the table. You could also use vices or clamps or any other work holding to make sure that your material is in the right position, in place. You just want to make sure that it can't go anywhere when you hit the material with your cutting tool and tooling. So again, make sure you see me about speeds to set up your feed with regards to your materials, so that you're able to achieve the right feeds and cut through your material when necessarily. We will be moving forward with other tools here with this bracket momentarily.